Hello, welcome to the next edition of Raku Reviews, week number 82 and the task number 1, which is called Common Factors. You are given two positive numbers, m and n. Write a script to list all common factors of the given numbers. Right, so there's an example, the couple of numbers 12 and 18 in the input, and the output is this list, because the factors of 12 are these, and factors of 18 are these, and their intersection is just 1, 2, 3, and 6. Let's check 1, 2, 3, and 6. That's correct. So simple. Here's the second example. There are no common factors. 23. There's only one factor, prime number, and the common factors is only one. Right. Okay. Let's go to the list of solutions in the Raku programming language. Let me start with my solution again. And here it is. So there are a couple of numbers that I read from command line. Then I scan the range, not bigger than the maximum number, right? Then the minimum number, actually. No, that the maximum number. Actually, probably it's too much, right? Because I probably could use min here because what's the goal of trying to find bigger numbers if it's by definition it's not divisible by this number? Okay, so the first thing, probably we can change this, and then I grab and I filter number which are divisible, where you can divide $A by this number first, and then another grab where you can divide B by this number. Right, so probably you can, it's kind of like vertical bars, the pipes in command line, all these grabs, but probably actually we can even use the feed operator equal more, right, in this example. But nevertheless, so this solution, let's test it. Raku ash Raku ch 1, 12 and 18. This is the result that we saw in the definition of the task, right? Second example, Arne Sommer. We are reading a couple of numbers, positive integers from command line. There are some command line options. And after that, we determine the factors of m and factors of n. And if the key include self is there, then we scan the range, which includes the number itself, right? But actually, probably that's only valid for the case when the number is like multiple of the second number, right? And otherwise we scan it up to second. Probably it's kind of equivalent of square root here for this task. You grab it again, you find the numbers which are divisible, and you do and you do it for one number, you do it for second number, and after that you just take the intersection, right? So that's simple. The only thing that I wanted to maybe test is, for example, if I have my A is 1, 2, 3, 4, 5, my B is like 3, 4, 5, 6, and 7, and their intersection, what is the intersection? What is the type of that thing? And so A ampersand, I'm not using Unicode here, it's difficult to type from the keyboard, right, it's a set. So you see, so it's a set, so it's not an array, so it's a set. And probably that's why Arne used hash here, just to, because after that we take keys, we sort that and print it. Raku ku Arne Sommer Raku ch 1, and the same numbers and the same result. Right, good, very good. Feng Chang Raku 1. That's a brief solution. So there are a couple of unsigned integer which are both defined. I wonder how can I enter the undefined integer from command line, right? Right, so this is what I noticed in my solution. So definitely it should be minimum of those two. And again, you see, so the difference, there are two ways of using this minimum as the infix operator or as a function. Actually, as a method as well. So probably you can put it to like .min. And after that you grab, here is an interesting solution. So here you grab, there are no two grabs, but there is only one. But inside we do not test a single number, we test the junction with this ampersand operator, and it should be like both this number and this number should be divisible by the current number in the loop, right? That's cool, I really like that. So it's all junction, right? Raku, Feng Chang, Raku ch 1, 12, 18, and the same result. So far we have three solutions, and all three solutions, this is the different one, this is the different output, but I do not care. Right, Jan Krnavek, a solution with and then, I believe, yes. What we do here, there are a couple of multi-main functions. This is the one which reads the numbers from command line, and then we just use two space. Common factors of this, common factors are, we determine the great common divisor, right? GCD, and then we use this. So you see, so there's a semicolon here, so it's a separate instruction, right? Separate statement. And we scan the range. Actually, it's not the range, it's a sequence, right? 3 dots. 1, 2. Actually, probably range would be simpler, right? 1 ... GCD, right? The same. Okay. And then we grab that. I really like how you can read it just in natural language. And then you grab it using this condition. This bigger number is divisible by that current number. That's smart. That's smart. That's employ some mathematics. Raku 1 bash Raku 1 1218. Right, the same correct result. Right, Kang-min Liu, Raku number 1. We take the numbers from command line, we determine the common factors, we join this by space and print it. Common factors, 2 numbers, integers. Right, exactly the same, so GCD and up to this GCD. Basically the same solution, but just written differently. So here we use the range, as I mentioned just a second earlier. And after that, you've got this pointer block inside the grep. And you take check the divisibility, right? Raku Raku 1 1218, right? Yeah, now finally it's the third type of the output without any in parentheses, right? Mark Anderson, Raku 1. So the solution, so we take a couple of integers, again, so this greatest common divisor, and right, we scan this. Yeah, this is what I mentioned just a second ago. We scan this range. After that, we grab that, and print the list. Notice that there's only one in this type of solution. There's only one grep. Unlike my solution, for example, we have 2 greps, one after another. And actually, unlike the solution with the junction inside the grep, so there's one grep, but actually there are a couple of them, right? Because there's a junction. Here in this solution, there's only one grep, no junctions, nothing. Right. So Raku Mark Anderson Raku 1 1218. Right. So this is the correct result. Markus Holzer. So a couple of integers from command line. What we do, grab all. So here's the junction. The junction, different form of this all junction, divisible by this number, and this number actually goes through 1 to maximum of those 2, right? So max. So the absence of parentheses maybe makes it a bit more difficult to read, but actually it's quite clear. The maximum takes these 2 numbers, right? Right. So grab all of these numbers which are divisible, both of them. And so this all basically means both, right? And right, so you do not include the maximum itself. Right, okay, well, let's test it, but definitely it will work. Markus Holzer Raku 1 1218. Right, that's correct. Philip Hood. Couple of integers with some defaults, and wow, that's cute. Let's okay, so we determine the greatest common divisor, and we use the same grep with the same kind of pointer block. We saw this type of solution earlier, but the interesting thing here in this solution is the additional interesting thing here in this solution is that we determine basically another variable inside the command line. Actually, it's a good trick probably for Raku Golf, right? So you just actually avoid using the my, right? If you just put this variable declaration inside a sub, but actually you need this submain, right? But if you're reading from command line, actually that's a cute trick, yeah. I probably should just take note of that. Okay, but nevertheless, let's run this solution. Raku PKM in Raku Ch 1. There are some defaults there, and yeah, the result is correct. Good. Simon Proctor. Here's the solution. We take a couple of integers and this factors number. So factors number of m and m, and we determine the intersection of those. Basically, this is a set. Again, we take the keys of this set and sort and join them, right? And how do we do these factors? Right, so it's up to the range. We scan the range and we grab if it's divisible by the current number in the loop. Right. Okay. Raku, Simon Proctor, Raku Ch 1, 12, 18. Right, the same result. Definitely it's correct result. Good. I like this. Yeah, the intersection is really cool. Athanasius, Raku 1. So here's the, yeah, there's the comment about like if this, yeah, should we include the number itself or not. It's not quite clear from the definition, but nevertheless, so there's main function, probably it's positive integer, that's correct, defined, and what we do, okay, so that's a bit different. So set pos, what is set pos? That's a set of, so this container has the elements of this. Actually, no, this container is the, should contain the content of this type, right? The object of, which is a set of positive integers, right? That's a bit, woo, wow. Right, nevertheless, so this array contains positive integers as its elements, and it's again the intersection, but it's a Unicode character this time. Key is sort, we saw that. And, right, so we create the new object, the new set, and fill it with divisors. And how do we determine the list of divisors? Well, actually the array of divisors. Yeah, well, it's really strictly typed. Divisors, we fill it with 1 first, then we scan the numbers up to the square root of that, and if the number is divisible, we take the number itself and the inverted number if it is also divisible, right? Okay, if reflexive. Okay, and after that, oh, there's some explain function. Where is it entering? If we want to print some debug information, there's an explain function, yeah, which just explains the thing. Right, so let's run this. Raku Athanasius Raku Ch 1, 12, and 18. Right, the is factor of, where is the answer? Okay, yeah, here. Okay, the explanation is also turned on by default. Right, okay, good. Let's go next. The next solution here is a solution by Colin Crain. Here's the solution. So we take the numbers with some different defaults. Yeah, this is the case where it will be important to include or not include the number itself. Bag factors, yeah. So the new type of solution is bag, not set, not hash. Factors, unique, sort, factors of n, right? And this is factors of m. Okay, so it's a bit like non-symmetric thing, but nevertheless, why not? Factors of m, factors of n. This is how we determine the factors. We gather and we take the number itself, and yeah, in this range, we grab this and yeah, we take a couple of numbers in one go. Right. And after that, so I wonder where do we determine the intersection? Here. So, and after we do all of that, unique. This is probably, yeah, it's unique. Why should you? It's kind of a simple task. It should give already the unique results, but nevertheless, you're right. Sort, grab. You only take the numbers which exist in the factors list for the second number, right? And here you are. Okay, right. Raku, Colin Crain, Raku Ch 1. Right, so this is the test output for 18, you see, so 18 is there. And for our test case is this result. Right, fine, it's different output in square brackets. Right. Jaldhar Vyas, Raku number 1. Right, so what we do the intersection of two lists of factors, right? And factors, yeah, so here we scan the range up to half of the n and check the divisibility here. So you see the divisibility operator is really commonly used here. After that, we take the intersection, which is a set, as you remember, and you take the keys, sort, join, right. Say Raku, Jaldhar, Raku 1, 12, and 18. Right, the result is this. Good. Julio de Castro, Raku 1. Oh, that's a really interesting thing. So we take, yeah, okay, okay. So yeah, that's there are lots of slashes and actually different forms of slash. It's not regular slash as far as I can see, right? We'll check it in a second. So right, so there's a function main that takes a couple of unsigned variables from command line. This is A, this is B. Both are integers, positive integers. And right, so this lets us this is basically the sigle-less version of Raku. And here is the variable. So this is not a sigle anymore, but this is something different. This is the prefix operator. It returns a list of devices. So actually, yeah. So let's just find this in Google. So you see, it's the so-called division slash, right? So it's not just regular slash. You see, so there's some difference in between those two characters. This is the character with this code, right? So, and this division slash we use as the operator, the prefix operator. We scan the half of the thing and the number itself. Yeah, so it includes the number, right? And we grab, yeah, so the numeric value. No, it's not numeric, it's a variable name. Oh, that's confusing when, well, at least syntax highlighter doesn't send that this is a variable, right? So that's the sigle-less variable. But why on earth do you need this, actually? Right. Okay. And I mean this plus. Why do you really need that? And after that, oh, actually, there's another thing, right? So there's the intersection operator as is it the Unicode character? Yes, it is. So the this is list, but why do we need actually this intersection operator? Because we want to convert this to something that we can directly output without printing these keys, sorts, and list, right? So yeah, okay. So basically, this infix operator appends these three method calls to this, right? Okay, cool. Well, interesting this, but it will be a bit slower than other solutions because Raku needs to compile those additional operators and build it into its grammar. You see, so it's slower. And again, to speed it up, you should just move these two definitions to a module, and then after the first run, you will get the cached model on disk, and Raku will just use it. Right, Laurent Rosenfeld, Raku number 1. Yeah, Laurent experienced some issues with the terrorist things in this city where he lives, but nevertheless he managed to submit the solution for this task, and this is the function common factors. Well, maybe I want even to use the right, to syntax highlight this. So common factors, integer, great common divisor, and if this is 1, we print 1. Well, we return 1. If this is prime, we print that, because yeah, if it's prime, there's no need to scan it. Otherwise, we just scan this and determine the unique things. Right, so Raku, Laurent, Raku 1, 12, 18. Right. Okay, very good. Okay. Myoungjin Jeon, Raku 1. So we read, so we read a number of numbers from command line, and this number of numbers should be only like with 2 elements, and all of them should be integers, and all of them should be positive integers, right? Right. With that's cool. Greater common divisor is inside the reduction operator for this n, so we typicalize. So we in one go we determine this this value, and we typicalize that, and after that it's inside this $_ we scan this array and grab the things which are divisible. Yeah, here's another sigle-less variable which is used here. Right, okay. Raku Jeon. Oh, sorry. Oh, there was a solution in Go, right? Interesting. Chip 1, 1218. Right, yeah, maybe I just want to take a small, no. Oh, yeah, right, because it's here. Small look at the, wow, Haskell Perl. Wow, that's cool, but nevertheless, Elm. I mean, just how difficult is it to write in Go? Wow. Okay, right. Okay, the next solution, Roger Bell West, Raku number 1. So what we have here a couple of test calls, right? Just factors. There are two functions, factors and common factor. And these tests just test the functions, but this function is not enough for the result. And this is the function that does the final job, right? So it uses these factors. So how do we determine the factors of the number? We create a hash and fill it with a couple of numbers, 1 and the number itself, and after that we scan all those numbers up to the square root of that. If this is the number, we append it here like to this, well, yeah, set hash, and we also put the inverted number. It's like number divided by, and that's it, right? What's the correct term in mathematics? Right, so common factors. It's, so we map, what do we map? The at underscore, so we map the past numbers, right, and convert them to factors, and we have these, and after that we pick the numbers from this map. Well, actually it's an array, right? And while there is some number, so we scan the number, we do the intersection with the next thing. Oh, okay. Yeah, Raku, Roger, Bell West, Raku, chair 1, test things there. It's everything correct, and this is the result that we expect for this, and that's right. Okay. And the last solution in this list by alphabet, Ulrich Rieke, Raku number 1. So we have two numbers. We determine divisors. Why do we need to use V6? Right, and how do we find these divisors? Is we scan the range and grab, right, the numbers which are divisible. And after that, there's an intersection. And again, interesting thing here. Nevertheless, we saw many solutions, but this week it's, I think, the first solution where we have the interpolation of a code block inside the output, right? Which is really cool. So you convert this to set. So you see, so this was the arrays. Actually, probably this one is not that important because we saw in the second solution, probably Arne's solution, that's like it was array and their intersection after that. But I wonder what is the output of this, because we've got the set in result and we don't do any conversions, right? So Ulrich Rieke, Raku, 1, 12 and 19. So we see, so this is how this set is interpolated, and the number of arguments, yeah, is different every time. Oh, nevertheless, yeah, so at least we got some new output. And that was it from the task number 1 of week 82 of the weekly challenge. It's not Perl anymore. Right. Nevertheless, yeah, so there's a second solution. There's a second task in this week as well as usual. Until if screen. So, but yeah, thanks for watching this review. See you.